Okay, it says workshop here, and I do hope Jim just asked whether this is going to be interactive. I hope that it is. Otherwise, filling 3 hours will be a bit of a trick. I've put together a list of topics that I think are worth discussing when you think about moving to Unicode. And we'll go through them, and I hope, interrupt me at any time to ask questions. That will make this much more useful, I think, for everybody. How many people in this room have actually fired up version 12 Unicode and played with it enough to sort of have some sort of, have seen a Unicode, a character that wasn't in Quad AV? Okay. That's not bad. And how many people would say that they think they know what Unicode is? Okay, so we should start with a bit about that. So I'll start with what I think Unicode is, talk a bit about how we thought about designing this version, the Unicode version, what we were trying to achieve, introduce the new features of the language that have to do with Unicode, that are there to support Unicode. And then the rest of the discussion will be about the kind of things you need to think about when moving your code. What's going to be different? What are you going to have to change? What might you want to change depending on what you're trying to achieve with your Unicode migration? Everybody who is using APL, or I would say any computer system at all, should be thinking about moving to Unicode. Eventually, Dyalog will cease to produce a non-Unicode version. Eventually, we must, because it's just too painful to continue with the old system. So, how many people here are thinking they want to migrate, say, within the next year? Okay, that's good.
One.
Ask at the end.
I'll repeat. I should repeat the question at the end. Okay, so a lot of people here are actually thinking about trying to move quite fast. That's good. The sooner the better. Okay, so what is it? Well, according to Wikipedia, it's an industry standard allowing computers to represent text expressed in any of the world's writing languages. That's the goal that the non-profit consortium had when it sat down, and I think it's almost 20 years ago now that the first, certainly 15, right? The Unicode standard is 15 years old. But it's only in the last, say, 3 or so that I feel there's been sort of enough support for Unicode in the platforms to make it really interesting to use Unicode. Where's that light coming from? I guess that's unavoidable. Yeah. So, I don't know how many people were involved in this. I think it was a very large number. They sat down and assigned a number, or a code point, they call it, to each of approximately 100,000 characters. And this, there were battles and there was blood on the floor over many of these. But now we have it. And of course, APL is recognized as one of the world's writing systems. So the APL character set is also in there. And there are a bunch of people, I guess, Bob, you were involved on the APL standards committee getting the
towards the end of it.
The APL character set into the standard. When was that? It must be 10 years ago.
It must be 15 years ago.
15 years ago. It was right, when Unicode emerged, right?
Yeah.
And every single APL character that has ever been used, or I think considered by many APL language vendors, all the little boxes with arrows in going all directions. Okay, Micro APL did
basically
use
the
those.
outer product of all the overstrikes.
Outer product of all the overstrikes. And they got everything right except there was some trouble with tax, but we won't talk more about that.
I think they're just labeled wrong.
They're labeled wrong, but they're in there. It appeared in 91, and now it's really becoming supported on all the platforms. So Windows, Unix, Linux, you can get enough Unicode support to really want to use it. So why do we want to use Unicode? Well, there's the obvious reason. If you have an international application that you want to move around the world, and you've got Chinese customers who want their names in Chinese, you can do it. You need Unicode for that. Or it's certainly much easier if you want to support many different languages. And less obviously, but perhaps more important for many of us in the short term, is that Unicode is an opportunity to the APL community to simplify how we do a lot of things. We don't any longer need our own character set. The idea of an atomic vector, each APL system having its own list of typically 256 characters that it used, different from ASCII, different from ANSI, different from what everybody else was doing, requiring translation as data moved in and out of the APL system. That whole idea can just be discarded. And some people will turn up their noses at the last point here. We can put our source code out. We can get our source code out into ordinary text files. And then we can use all of the standard tools for source code management, building applications that, millions of euros, dollars, whatever, have been invested in making these tools. Some of them are very good. Some of them may seem a little bit alien to us at first, but certainly for large applications, these tools are very, very useful, and we'll have a look at some of those. So, I think many of us don't actually have the top problem that we have to have customer names in Thai or dozens of different languages, but we all have this last part. I think is very useful. It's going to be very useful. Right, so some examples of what's in there. A sample of these 100,000 characters. The first one there, A, that's part of ASCII, part of ANSI, sort of a character that we're all very familiar with. The columns here, the first one is just the symbol. The second one is the official Unicode name of that symbol. Typically when you're working with Unicode, when you're looking it up on the internet or whatever, it'll be the hexadecimal representation of the Unicode code point that you're looking for. In APL, when you're working with integers to represent them, if you have to do that, you would probably use a decimal representation. And then if you want to store them in a text file, in fact, if somebody tells you that the data is Unicode, what that usually means is that it's a file which is UTF-8 encoded. So there are a bunch of different encodings. We'll get back to that later. Every character has a unique number or code point, but there are different ways that you would store that on a text file. So UTF-8 is an encoding that is very common because it's compatible with ASCII for the first 127 characters. It's just a single byte, so you can't tell the difference. So if you're an American, you can sort of put your data in there and say it's UTF-8 and forget about it. Everybody else then has to know how to encode it into varying numbers of bytes. But this has become the most common form for storing Unicode text. The internet is a very useful resource for this. If you want to know more about a character, you can just go into Google and say Unicode and the hex. If you type the decimal, you'll probably also have a good chance of finding it. And then there's lots of links where you can go in and get information about, what are the characteristics of this character. Is it in a font that goes from right to left, I think, yeah. And can it be uppercased, and is it a valid name in a programming language, and all this kind of information. The Unicode characters have all that kind of classification that you can look up. And if you want to learn more about Unicode and encodings and so on, Wikipedia is also a very good place to start. There's descriptions of all the encodings and the history and problems that you might get into when using Unicode. Okay, so we mentioned encodings. Right, so there's a unique number, but there are many different encodings, and those encodings have varied over time. Here are 4 of the most common ones. The encodings have 2 types of names. Either they begin with UCS and are followed by a digit. That means they're a fixed width encoding. So UCS4 means Unicode represented using 4 bytes per character. UCS2 only uses 2 bytes, and that was fine for many years after the standard was created. There were less than 64,000 characters, and 2 bytes was sufficient. So in Windows versions until Windows 2000, 2 bytes, UCS2 was generally the representation that was used. And then the Unicode consortium added more symbols. They have promised now that you'll never need more than 23 bits or something. I guess until we make contact with Klingons and other... actually, Klingon there's already space reserved for Klingon, so that won't be a problem. But okay, and then after Windows 2000, UTF-16 is used because Microsoft realized... Microsoft actually, strangely, in this case, was ahead of the game. Microsoft had support for Unicode long before it really started to be properly supported in Unix. And for that reason, they have the problem that they started out with what is now an obsolete form. Most Unixes internally use UCS4. Windows, because it started with UCS2, now uses UTF-16, which is, again, identical to UCS2 for most of the, tens of thousands of common numbers. But UTF-16 has bits where you can say, well, oh, this won't fit in 2 bytes, so you need to look at the rest, some more bytes as well. So for almost all characters, the UCS2 and UTF-16 representations are the same. But if you use some of the most recently added Chinese or Korean characters, you actually need to switch to UTF-16. And that actually is the source of bugs in code still today, because people assume they're using UCS2 and they put UTF-16 into it and so on.
These encodings that are not fixed width, how do you tell, is there some way you can tell like where it starts and ends? Is it...
Yes, I don't know this well enough. Mick might be able to answer, but certainly the UTF formats are such that you can easily recognize the beginning of a character.
Oh, okay.
Yeah. So even if you start in the middle of a file, you can sort of synchronize to the nearest whole character, right? Yeah. So these things are very well designed from that point of view. The problem is only that because it took people 20 years to get started with this stuff, and there were less than 65,000 characters to begin with, and then UTF-8 is there because it was compatible with ASCII, right, with single byte. But the way things have worked out now is that UTF-8 is the format that is generally used. If you write an HTML web page, you would usually encode it using UTF-8. So that for ASCII, for 0 to 127, it's the same as ASCII. And then if you have code points from 128 to 2047, it requires 2 bytes. APL characters are up here, they require 3 bytes, and then nothing requires more than 4 bytes. So actually there are 2 reasons why UTF-8 is... We're probably going more into encodings now than we should. We should perhaps return to it later, but there are 2 reasons. One is it's identical to ASCII for the first few characters. The other is that it's the only encoding which is independent of whether it was written by a big endian or a little endian computer. So Intel, because it's a byte at a time, it doesn't depend on the endianness. Whereas UTF, all of the others will have the bytes in a different order on an Intel computer than on a... Okay, so after a bit of a digression into encodings, we'll get back to that. So, and these foils are on the memory stick, so don't worry if you didn't remember all that. What did we want to achieve with version 12? Well, obviously, to allow you to write applications using all of these symbols, goal number 1. The second one, of course, was to make Dyalog, the Dyalog application itself, a Unicode system, which meant we could deal with APL with no translate tables. We could use the same kind of fonts that everybody else uses, same kind of keyboards. When we designed it, we thought, well, should we have two kinds of characters now? Should we have single byte quad AV based characters and multi-byte characters? The APL vendors who did this before us chose two different approaches. IBM had two kinds. They had a multi-byte fixed width and a single byte quad AV based representation. J has two types of character variables. One is just UTF-8 encoded strings, and the other is it double or quadruple byte?
I don't know.
Probably 4 byte, I hope.
I know that Eric was swearing at the design decision they made some time ago. So
the problem in J is if you type, say, a Danish name, quote something with an AE in it.
Angster.
And compare it with another string, you get which you think has the same number of characters. You're likely to get a length error because you're comparing UTF-8 byte by byte. So in fact, string searching and dealing with... So we didn't want to do that. We really wanted to say, well, it may be slightly more work now in converting applications, but we want to end up with just a single form of character. We don't want two kinds of characters. And we want characters where one symbol equals one element of an array. That, for an array language, that felt fundamentally important to us. And then most of the work in putting version 12.0 together was to try and design it in such a way that we would encourage people to migrate. So we wanted to make it possible for the old and the new world to interoperate. Although we don't have two kinds of characters in the same interpreter, we have two versions of the interpreter that can share data, share workspaces, component files, and so on. As usual, we think this is very important to our customers, that they don't have to convert all their data at once in order to use it with a new version of Dyalog APL. So we have a Classic and a Unicode edition of Dyalog APL from version 12. There are two versions of the product, and we'll get back to that in a bit. So the key features of the Unicode system are that we now have 3 character data types. Now, I said there's only one. These are internal types. Right? When you're writing APL code, just like when you're using integers, you don't know whether you've got a 1 byte, 2 byte, or 4 byte integer. You can't tell when you're using characters except with quad DR whether you have a 1 byte, a 2 byte, or a 4 byte character. But we wanted to avoid all data blowing up to take 4 times as much space as possible. So if you have data which is in the first 256 elements of Unicode, which is almost the same as the ANSI alphabet. I don't know why, but there are 3 or 4 characters which are slightly different. So if you just have a string which contains normal Western European text, it'll be 1 byte per element. If you have something with APL arrays in it, it'll be a 160, 2 byte. And then if you have some of the recently added Chinese characters and so on, they will require 4 bytes. But we do the usual stuff of compacting it when we can.
So quad AV is now 2 bytes. Quad AV is now 2 bytes wide. Is that the story?
We'll get back to that.
Okay.
Quad AV, I think now is a function. Officially a function.
All right. Well, okay.
Okay. So
the result elements I get back from quad AV, that array, the quad size of that array would be
will be 2 bytes.
Yeah.
Certainly
okay.
with the default quad AV.
Yeah.
But see, quad AV is now just a function.
Okay.
In fact, it always has been, but people haven't really been aware of that. Okay. So no. Yeah, I've explained that. There's a new function quad UCS, which is this identical to the one in APL2, IBM's APL2. I think they've had that for a decade or so. So you give it a string and it tells you what the Unicode code point numbers are.
And
Yeah.
Morten, this works only in the Unicode version?
No, Quad UCS is also there in the classic version. We'll get back to that. The first two expressions would have work in the classic version. If you tried this if you try this one in the classic version, you would get a new error called the translation error, because you've generated Unicode characters which are not in Quad AV, so the classic version cannot represent them. But Quad UCS is there, and Quad UCS is self-inverse. If you give it Unicode code point numbers, it returns character array. If you give it character array, it returns the code point numbers. Okay. And then there's a dyadic version of Quad UCS to deal with these encodings. In fact, it only supports the variable length encodings because the others are trivial to deal with. Or you could do the others with Quad DR, I suppose. So if you do that, it gives you, in this case, you've got A, B, C, and then E, U, O.
How would you type that in from the keyboard?
Well, on a Danish keyboard, I have all of those characters on my keyboard.
So you just have a stack of keyboards available. Plug it in.
I'll show you. I'll type some Japanese a bit later. Yeah. And so here's our Chinese. Now, obviously, I mean, you can't do this stuff in your head. But you might have read these numbers off a file or whatever, and then if you read a file and you know it's UTF-8, then you can turn it into the characters using Quad UCS. This is something that APL2 does not do, as far as I know. It doesn't have dyadic.
Is that just a catenate? The catenate is just
Yeah, this is just to show you
show you
that there are three
characters
symbols here.
okay.
So that's the first one, the second one, and the third one. Yeah, that's one line of APL there. Yeah, and then those same characters could be represented using UTF-16 as two double byte. But I don't think those are the same. That's not the 256 encode of, is it decode of that?
The encode is over the N.
Is the decode. Okay, demo it says. So let's see if I can get this to work. And think of some questions in the meantime. Just going to load a script here. Intro. Okay, is that big enough? If not, move closer. It's supposed to be interactive, so it'd be better. So yeah, this is just, no cards up my sleeve. That shouldn't be a surprise. In fact, all of what's in the demo here should be something you can work out from the slides that have been. So that's ABC is just a single byte per element because all the numbers are less than 256. And here's an 80 on the left and a 160 on the right, and you just compare them and it does it element for element. You don't have to, as an APL programmer, think about, I mean, the only difference between them is how much space they consume in the workspace or on a file, of course. And that is an issue. Okay, so we can have these characters appear in the session. That's a 320. And the code point numbers are big. Quad AV. Yeah, there it is. Our old friend Quad AV. It's still there. We don't need it at all in the Unicode version. But it's there simply to facilitate interop or, moving old code. If you have an expression, first this. So a character array, the elements of a character array do not have to be elements of Quad AV. Right? But this expression, if you have that in your code, will return exactly the same result as it did in version 11, and the same result that it does in the classic version. So it's there simply to allow you to easily migrate. Yes, Jim?
Is there only one space the same everywhere? Space character? Or is that function point or something unique?
You mean blank?
Yeah.
Blank?
Yeah.
Yeah, there's only one, as far as I know.
Right. Okay.
And it's where it used to be.
It's where it should be.
Yeah. But these days you should not say quad AV sub 5, you should say quad UCS 32. Right, because
So-
space is
Well,
32.
quad UCS quote blank quote, just to make sure we get a 32 back.
Yeah, some
Oh,
people
cool.
have no
But
faith.
Well, it's fine. No, I just about had my...
Yep.
So for those of us that have large legacy code bases,
Yep.
underscore characters, you're going to get to...
We'll get to underscored characters. There's a whole folder, just maybe 2 about underscored characters. Yeah. They are there, but if you have any, you should be thinking seriously about getting rid of them. Okay, so italic's not there either, or bold. Okay, so I mean, this is just showing you can take ANSI numbers that people are already familiar with, or some people may be familiar with, and generate text instead of using quad AV. Okay, so here's a function to convert hex to decimal. I'm not sure why I have that in this. Well, it's to... Oh yes, this was for a version 11 presentation. The interesting thing about this here is the decode to the power -1. And the point about that is that if you say hex and some number, it figures out how many digits it needs automatically. That's a version 11 feature. Before you always had to do this, something reshape 16 on the left argument. But, the power -1 always, tries to select the simplest result that would satisfy the... So it does that backwards. Yeah. Talk to John Scholes about that if you disagree. So if we've looked up Greek on the internet and figured out it starts at 0390 hex, then there they are. So let's make a little array of languages that we'd like to see. Okay, so I added as another column the hex of the left argument plus iota of the right argument reduction of the second and third columns. Right, so that extracted that piece of Unicode and added it as the fourth column there. And okay, so this is to show you some of this about storing APL source code in text files. A slight diversion here. So I've written a little thing that because I want to do a multimedia presentation. You're always supposed to try and do that. So I have a little thing that plays sounds, and I've just implemented it as this little namespace here, which is in a notepad file. And quadac.salt.load loads that into my workspace, and I can play. I don't know if there's any sound. No. Oh, here we go. We were just waiting for the .NET framework to fire up. My timing's off. Okay, so we can... That's the end of the presentation, actually. I mean, what more do you want? Well, there's some interesting design questions. Well, obviously you would expect this, but what do you expect to appear when I hit enter here? That's Hebrew. It goes from right to left. In fact, when I try and print these presentations, I get into big trouble because Word and PDF files and so on know that they display that the other way around. But we took the view that you want to be able to do things like this. You want to be able to predict what's going to happen. You want APL is an array language. It's not a string language. That is a 3-element array of characters. Aleph, beta, what do they call it? Gamma? Probably not. And the lambda. And the third one is so we do not in the APL session reverse the display of Arabic or Hebrew or anything like that, because that would make working with arrays pretty difficult. But let's create a form. There we go. And let's put the Hebrew, so we put the Hebrew into an edit field, and the Windows control knows that that should be displayed the other way around. Right?
What does it mean?
What? Oh, it's just the first 3 letters of the Hebrew alphabet. Doesn't mean anything unless you're a Jewish kindergarten pupil. But see, now if I type some Danish in here, and then I move the arrow key, I'm selecting stuff a character at a time. Yeah.
Oh, good.
But see, we don't do that, right? John Daintree didn't have to do anything to make that work. That's just part of the GUI control. Right? Otherwise, it probably wouldn't be finished yet.
So Morten, that brings up your question you talked about things that may appear to be the same, but are not. So presumably things look differently enough that you can tell that that is the correct behavior. But if things, if you had 2 alphas, for example, and they were...
Yeah. I mean, that's just... Unicode does not solve all the problems in the universe. And we'll have a look at some more of those. Okay, so now I've installed a Japanese keyboard. I hope I'm not doing something rude here. Oops.
Also, it doesn't mean that
Other Japanese.
this control just writes characters as handwriting, one by one. Because it's not just a page of the same stream from APL session to the control as we used to. But the control behaves as we were writing that in Arabic or whatever.
Yeah, the control knows how to deal with an Arab or a Jew
But the
typing.
word deal,
It knows how to deal with Japanese
the word
people
deal
typing.
in this case needs some interpretation.
Well, it means that the keyboard works as that person would expect it to. So, okay, now if we extract the property f.e.text here, yeah? Now if I copy, okay, I'll copy this, copy, paste. You see, it's not the same when I paste it here, because that's what you see there is not the order of the characters in the string. The order of the characters in the string is Aleph, Beta, Lambda, but it displays the other way around, and I don't know anything about that, but if you talk to somebody from Israel, they will explain to you.
What's the difference in this control than the controls we've used in the past? There are no differences?
No, this is just standard Windows behavior. Yeah, this has got nothing to do with Dyalog APL at all. The only difference in version 12 is that in version 11, if you typed f.e.text here, it would have said right? That's the only difference. Because now that when we read these Unicode characters into APL, we can say, oh, we know what that is. That's just, that's just Unicode. Yep. Now, of course, if you're writing an application, I don't really know how to advise. I can't tell you anything about how to write, what a GUI should look like for an Arab to be happy with it. Absolutely no idea.
Well, there's a difference between Arabic and Hebrew characters because when they're written in sequence, they have different forms. They're at the beginning of the word, the middle, and the end. Whereas in Hebrew, they're not. They're the same. They look the same.
Yeah, and
And so I don't know if they have different code points for that or not.
I think they probably do.
Yeah.
Well, they must,
Yeah.
because they can represent the...
But usually-
And I think, I mean, in many languages, I'm not sure I'm able to demonstrate that, but you use, if you switch to Japanese, no, I don't know how to enable that. There are some forms of Japanese typing where you'll type a few symbols and then it'll pop up,
Yeah.
and you have to make some choices because you've typed something. You've typed the beginning of something, and it
Yeah.
needs you to. It's like texting with predictive text. So there's actually a whole user interface in between a Japanese person and Windows, which is allowing them to construct these symbols, and then only when they've finished that process do the Unicode characters appear in the edit field.
I mean, is this what it's supposed, that up there in that other window is what it's supposed to look like, and down here is just what it's looks like in APL? Is that, so if you were to put some consecutive Arabic characters in there, I could probably tell you if it looks like. I'm just curious.
I
Yeah,
only got Arabic numerals.
Yeah, well, if you can just grab a couple of those characters. Well, no, on right above it, those characters.
Ah, okay.
Yeah, just grab a couple of those and put them together, and see, that doesn't look like Arabic. That just looks like a bunch of letters strung together.
Ah, there we go.
Yeah. See,
Yep.
yeah, then it's connecting them.
Yeah.
So they're different.
Whoops. Oh no, it deleted the other part. Okay, so let's put those in there.
Yeah.
So it looks
grab
like
a couple
that.
different
Yeah.
different ones and put those in and see what they look like. Yeah.
Well, I mean, even here you can see that
Yeah.
that, but that has to do with formatting rules for those
So
languages.
it's
that-
formatting the character.
yeah, we
but
don't
it's the
know
same-
anything about
yeah.
that.
It looks like it's formatting the character, but it's using the same code point.
Yeah,
Yeah.
it knows how to, and I don't know anything about what the Arabic delegation to the Unicode consortium, what kind of
What they
problems
did,
they
yeah.
faced and what they decided. I'm assuming they did
Yeah.
something sensible.
So if you want,
But I mean, we don't deal with that, right? We
Yeah.
we can't. We just,
Yeah.
you can put in the Unicode code points, and
And then you just let it happen there.
if you pasted that into Word, it would format it, I assume, correctly. Of course, sorting and searching these things is interesting.
Yeah, yeah.
and if you want to write
Yeah.
a APL programming help text that says the first three characters are, then you show the first three of the Hebrew alphabet.
Yeah.
It's not going to reverse that. It's going to show, the vector sub 1, sub 2, sub 3, correct?
Yeah, I mean, the
You
APL
can do
view,
that, and it's not going to flip it.
the APL view is an array is a collection of characters, of single characters. The first character, the second character, the third character. It's not a string. If we introduced a string data type in APL, then we would probably be obliged to format it according to these
I'm
rules.
with you.
Yeah. And in fact, Unicode may be a good reason to eventually introduce a string data type, because searching and sorting by comparing Unicode code points makes no sense in a lot of languages.
Well, maybe a reasonable way to view this is that this is similar to what you get from a format function operating on numbers. You start out with
Correct.
You start out with 1E6, and it's a scalar, and it's there. If you format it according to European rules, you get 1 blank 000 blank 000, which is certainly does not look the same. And if you put it back in, it wouldn't get the same.
Yeah.
So this is the display form, and that's the array form.
Yeah. And I mean, but APL is tricky, right? Because APL, it's a programming language that people use to build large-scale applications. APL is also a language that, let's see, here we go. Say you were an Israeli scientist sitting in immediate execution, and you wanted to have a variable,
ABC.
right? So now APL is not an application development tool. APL is the application, right? And in that situation, different rules might apply. And should he be writing that, or should he be writing that? And it's a good thing John Scholes is not here. And should a Greek person be allowed to write this? Right? There's an overlap between the APL symbols and the Greek symbols. And we chickened out of this. We haven't decided to add any characters to the valid characters for names in
They
languages.
have to be the standard.
They have to be the same characters that you could use in version 11, essentially. Okay, would anybody care to predict the length of the result of this expression?
7.
It's not going to be more than 3.
No? I'll leave now.
It's 2. Because there's a Latin A, and I think two Armenian capital A's in there. And in most of the fonts, you can't tell the difference.
So,
And this is something, again, we do not, at the APL language level, we cannot deal with this.
but there doesn't have to be a difference. They can be absolutely identical. Just
Yeah, and there are libraries for sorting and searching Unicode characters. You can read about it. There are books written about this. There are various forms of normalization of Unicode that makes things comparable, at the phonetic level, that would make these two A's. There are lots of A's, right? There's a Russian one which is...
May you do me a favor?
Yeah?
Just copy that AA and put it as a right argument. No, those AA.
those two A's. The one that
No, to the left.
The result?
right above you.
Oh, these?
Yeah.
Yeah.
Where are
Shaking
they?
hands.
Can't do it.
Oh, well, I use too many different... Oh, it's because I've got a Japanese keyboard.
Oh, you can just pop up with keyboard, yeah.
Here we go.
Oh, that's-
Yeah. Huh. Okay.
Yeah, I mean, there's no magic here. APL can't see the difference between those characters. Yeah, but yeah. So we didn't allow, but you can't take this A and say gets 99. Yeah, it's a syntax error.
Oh, that's weird. Yeah.
So you can get very interesting syntax. You can really make life difficult for the guy sitting in the desk next to you. So see if you can figure out why this doesn't work.
How did you get that Japanese keyboard and everything? I mean, you get it to...
How? Oh, I just installed it.
Oh, you have to install it.
Window, control panel, install Japanese.
You install any of a whole bunch of
Yep,
keyboards.
yep. You can have. I've got English. I've got lots of different things here.
The characters which can be used in APL names,
Yeah.
is that going to be extended at some stage to the Unicode set of characters which can be used within names?
I think it would have to be reduced to the Unicode set. Right, the delta underscore is definitely not in the list of Unicode names.
Modified to be the... so you can then...
Well, I don't think we can take characters away from people. I think at this point it's very unlikely that we would add, because interoperability between APL and other programming languages is getting more and more important. And in fact, I would say don't use underscores, don't use delta underscore, don't use delta, don't use any character in a name which is not recognized by other programming languages
I'm saying that Unicode,
because you'll regret it
that
eventually.
Unicode recognises characters which can be used as names beyond the Western...
It does?
yes.
Okay. We haven't looked at that because at the moment we just decided there are too many questions here that we can't answer, so maybe we'll extend it. But I think one of the very important things about APL readability to me is the fact that you can very easily see what's a user-defined name and what's a primitive.
I'm just thinking file names can use any Unicode.
Oh, file names, yes.
Yes,
Yeah, if the operating system supports it, you can use...
So would you be able to use, because the file name, you can have a name in Arabic
yeah.
in the file name, you should be able to assign an APL variable with that same name.
As soon as, well,
I
I'm sure
don't see that
as
follows.
soon as C and Java do it,
Yeah.
they'll do it.
Yeah. So, but I mean, at the moment we decided we're just going to pass on that.
Okay.
It's too difficult. We don't want to make a mistake by moving too fast. It's better to be conservative. And so that's what we've done. So we don't allow any of these things. Okay, so where were we? Okay, I'm now going to display some Unicode, just a quick look at some stuff in Unicode. And Adrian Smith's APL 385 Unicode font, which is now the standard used not just by Dyalog, but MicroAPL and other vendors are using that font in all kinds of publications and in their systems. Doesn't have all of the Unicode symbols, so I'm switching to Arial Unicode MS, which I think unfortunately is not a standard Windows font, but it's included with Microsoft Office. It contains, in fact, APL symbols. You can see some of them here.
Are those the actual APL?
I think some of those are. The APL symbols are sort of scattered around the place. Some of them are mathematical operators, and so there's lots of those. MISC technical, there's also some APL here. See, there's, what is it, fire hydrant. And there's the sharp APL stuff. I wonder if there's one with a dog.
Dog?
Yeah, a little picture of a dog to go with the fire hydrant.
Oh.
You can't read those, but those are control pictures that says no ETX. So these are all the ASCII control.
CRLF.
Yeah, CRLF and so on if you want to document those. Optical character recognition. Enclosed alphanumerics. So we haven't got underscores, but for some reason the Unicode consortium decided that the numbers from 1 to 20 with circles around them, except 0. And the numbers in parentheses and with a full stop following them. I suppose because so many academic papers or something use these, they decided it would be good. Oh no, hang on, here's 0 with a circle. Yeah. Yeah. Yeah, so underscores are not in Unicode, and what we've decided to do is to map the underscores to this range here, the circled alphanumerics. We'll get back to that in a moment. So if we switch back to Adrian's font here, you'll see that what was the circled numerics, if you remember where they were, has turned into... This is actually incorrect display of those characters, but in order to protect the people who still have lots of underscores, we decided that this was the elegant solution, was to put them in that range and for Adrian to display them incorrectly.
What's Quad AV look like in this? What if you can...
Quad AV, okay, well, we're back...
in demo land,
I can answer that. Quad AV, oh, let's see, what is it? 355 reshape. What? 65 drop.
Oh, okay. Thank you.
Yeah. It's not very nice. It
No,
is
it's not very elegant.
usable, but it's not pleasant.
It's not elegant, sure.
It's not elegant. Okay, so you may all remember. Oops. So here's a little function. I'm sure you've all been on introductory APL courses where they taught you to draw graphs. Now we can do better because there's blocks and shades. So we can now write unibar. Wow, it's smooth curves. So you've got 1/8 increments, right? We've got one here, up here, 1/8 steps. And you've also got them going the other way, so you can draw bar charts going the other way. And, those don't look quite so nice. Geometric shapes, so you can make IQ tests and stuff. These are fun.
A horse, no dog.
There's no dog. And John Scholes, who likes to put boxes around things and has been struggling as Windows would, Windows before Unicode was slowly taking one by one various box drawing characters away from him. He's now saved.
Hammer and sickle, no swastika.
No swastika.
The hammer and sickle.
There may be a swastika in there somewhere. I mean, I don't know. Unicode swastika. Oh, I mean, we may all get arrested now. The FBI, the CIA will arrive. We're not yet. We're already doomed. Yes. There's even a duck. Oh, I'm cheating a bit here. Here. It's a Chinese symbol. Duck. That means duck in Chinese.
Okay. Looks like a duck. Looks like a duck walking.
Yeah. Dingbats. Okay, now if you pick 50 characters at random from the first page of Unicode, it's almost all Chinese. Because there are 18,342 CJK unified ideograms. And there's an extension A to that with 6,582. These guys must have had a lot of meetings. Yi syllables, because the Chinese and the Koreans have they use the same symbols with different meanings. And getting in a committee to agree on that must have been, are they then the same symbol?
Tacky.
Chinese and the Japanese.
Yeah, and the Chinese and the Japanese. Yeah, the Koreans actually have these Yi syllables and Hangul syllables. Okay, and we switch it back to Adrian's font. Strange things happen, and so the Korean disappeared. Some of the Korean disappeared. Windows has these rules for if it can't find something in a font, and it's the same under Linux. If it can't find something in the font that was asked for, it'll go off and search through a long list of fonts. That's one of the reasons why, if I do this again, you'll notice, it takes time, right? And that wasn't deal. The delay you saw there wasn't deal. It was Windows going off to find those symbols in a font somewhere to display them in the session.
Got a letter A there.
That was lucky.
It's Armenian.
Oh, right. True.
Well, yeah, what is it? To prove that we can do it. Yeah, see? Now it's another one. Okay. Do you recognize this?
Yes.
Do not read it aloud, or the lights will go out. Okay, so here's a little defen I wrote so that I could quickly enter these numbers in the Tengwar Elvish. Okay, so here's the poem, the One Ring. And if I use a font, create a form with the font code 2001, it contains Tolkien's Elvish scripts. I couldn't find Klingon, but anyway, that's the end of the demo, the first demo.